Richard with EV4U Custom Conversions, and welcome to another episode in our series of how to convert your car from gas to electric. First off, I'd like to apologize for the background noise. It's winter here and we've had quite a bit of wind, and this is a metal building. The roll-up doors and everything else rattle and make a lot of noise. So don't know when it will be a good time to do this, so we're just going to do this, and so you have to put up with some background noise. I'm sorry. So in this episode, we're talking about a couple of things. First off, we're going to talk about to clutch or not to clutch, and then the rest of the episode, we're going to be talking about throttle control. So in regards to clutch, because we have another video that goes into whether or not you should use a clutch, I'm not going to go into that very much in this video. We'll put a link to that video in the description below. But what I will say is I'm going to quote somebody else here, in that in discussing to clutch or not to clutch, he used to always say that if he was building a car just for himself, it wouldn't matter if he used a clutch or he didn't. But he said if he was building a car that either his wife or daughter would drive, it would have a clutch. Food for thought. Personally, and if you watch the video, you'll see that I have a preference. All of EV4U's conversions feature a clutch or their direct drive without using a transmission. So one of the main reasons for that is safety, and the other is resale. You know, when you go to sell the vehicle, which most likely will come about someday, it will be easier to sell a vehicle that has a clutch just like every other manual transmission on the road, versus you having to explain how they need to shift this thing or whatever. So that's all we're going to say today about to clutch or not to clutch. We're going to spend our time talking about throttle control. Now, in the past, we talked about motors and controllers, batteries. Well, the controller, the term comes about because it does exactly what it says it does. It controls the motor. It is going to tell the motor how much power you want at any given time. And how does it do that? It takes a signal from the throttle and communicates that to the motor. Now, most vehicles are going to have a throttle pedal, whereas in the internal combustion world we call it the gas pedal or the fuel pedal or whatever. But we're going to call it the throttle. And that's going to send a signal to the controller, which will dictate your speed. Now, it's typically both a mechanical and electronic component. In other words, it's a mechanical connection from your foot to, a throttle body originally maybe, or a carburetor linkage or whatever. We typically, when we do a conversion, will maintain the original throttle and we'll connect to that with a piece of electronics, whether it be a pot box, a Hall effect, electronic throttle control, whatever. There's typically this mechanical electrical connection. So it's easiest if you use the existing throttle in the vehicle and then connect that to your pot box or whatever you're going to use. And I'll show you a couple of examples. I'll show you an example of electronic throttle, and a sample of a pot box. Couple, common types of throttles that we're going to talk about. And I'll show you what I mean when I was talking about the mechanical electrical connection. So there's that mechanical connection from the throttle, physical throttle, to your electronics, and then it's electrical to the controller. So you have electronic throttle, which is like a TPS, a throttle position sensor, or a Hall effect throttle. Those are examples of electronic throttles. And typically how those work is you have a 5-volt input signal, and then it goes to ground, and you have an output signal which varies from 0 to 5 volts. Okay? Then there's a 2-wire pot box style, and you have one wire will be the wiper and the other one will be pot low. And then there's a 3-wire pot box where you have a pot high, pot low, and the wiper. And then a lot of them, and like the Curtis PB6 and PB8, they come with a interlock switch. And again, I'll show you an example of that. And basically how they typically use this interlock switch is it's a normally closed switch. So you have continuity between these two wires. And that's a safety, so that if you get in the car and you turn on the ignition, if you had your foot on the throttle, the car won't just lurch forward and take off right away. If there's continuity here, that's telling the controller that the throttle is off and that the controller can turn on. If the switch is open and there is no continuity there, then the controller will not be activated. It will not come on. Keeps you from launching through the garage door or the wall of the house, whatever. Okay? So, what's real important here isn't necessarily the type of one that you use, but what's important is that it's compatible with your controller. Now, some controllers are compatible only with a pot box, like the early Curtis controllers. They're only compatible if you have a 1221 or a 1231. They're only compatible with the 2-wire pot box style. So you can't use the electronic one on those. Like the Curtis 1238 and 1239, they'll use all of these. Okay? So let me give you let me go grab a pot, and I'm going to show you why I prefer not to use a potentiometer. So here's a Curtis PB6 pot box. It's minus the pot right now, but normally there's an arm right here that you connect to, and that then activates the pot. And here's just a sample pot. Okay, you have a high and low and a wiper, and this rotates and adjusts the resistance. The Curtis is a 5,000 ohm resistor. And so this is the switch that we were talking about, little micro switch right here. And of course, it's a single pole double throw switch that they use. So there's a common, normally closed, normally open. And we're going to talk about switches in a future video. So if you don't understand what I'm talking about by normally closed, normally open, we'll talk about that down the road here. So anyway, I'll show you what this looks like in the vehicle. But the point I wanted to make was that there's no bearing or anything. There's a shaft that fits on this shaft, or there's an arm, I should say, it fits on this shaft. And that's pulled by your throttle cable or your throttle linkage. And so these mechanically aren't very good. And then inside, there's a coil of wire and a wiper. And that is a wear item. And those don't tend to hold up real well either. So you both electrically and mechanically, the pot box is not the best choice. So why do people use them? Probably cost. It's the least expensive route, but definitely not the best. Okay, here's an example of that Curtis PB6 pot box I was talking about a minute ago. It has a wire that comes off right here, and that goes up here to the controller. It's not polarity specific, but it's simply a pot, but it comes up to the controller. Here's the micro switch that we were talking about. You can see as I activate this, or I should say you can hear the switch. We're talking about connection. This is a VW Beetle. The stock throttle cable came in right here, a little off center. Okay, so the original cables, which we used coming back, is rather rigid, not a lot of braids, and it's great for a straight pull. So we attached to that this fine braided stainless steel cable that then makes the turn, another turn, and is in line with this. Because of the sensitive nature of that pot box shaft, and you can see it's a longer shaft than the one that I was showing on my example, but you want the forces on this to be as linear as possible and not causing side forces on that shaft and causing that to wear out prematurely. They have a somewhat limited life anyway, and so anyway, that's an example of a pot box. This is a two-wire example. So let's go take a look at an example of an electronic throttle. Okay, here's an example of an electronic throttle. You can see here closer the three wires we talked about. So there's going to be a ground, 5 volts, positive 5 volts, and then your signal out, 0 to 5 volts. And that will come into the controller. Now, this is a TPS, or a throttle position sensor, just like what is on most modern cars. So it's a very rugged piece, although I've replaced many in my days working on vehicles, but they're pretty rugged, and the best part is you can buy it at any Napa, Kragen, wherever. Now, so that's the electrical part. Now the mechanical part, it has a nice bearing, way overkill for something that only has, a limited amount of movement. It only moves so many degrees. It doesn't even go 360. Okay, and that, again, you have the throttle cable comes in and connects to it. Now this could just as well be some kind of linkage setup or other type of setup, and I'll see if I can throw together some a quick little slideshow showing some other throttle setups. So, placement. You notice these are placed close to where the throttle comes out in its stock location. It's by itself where it's not going to interfere with anything else, or nothing else will interfere with it. You don't want something getting in the way and limiting your throttle movement or causing a problem. Now, one of the things with using electronic throttle is that you set that electronically. So in other words, when the throttle is off, it's that position. You program the throttle. That is the 0 throttle position. Then you would open the throttle up all the way and program the controller that that is the full throttle position. That's what's nice about some of the, controllers. A lot of them are that way. You get to do that. Some of the old ones that were used at one time, the DC controllers, like the Curtis 1231 and 1221, they don't have that. You have to make sure that you have full throttle. You have to make sure that when you press on the accelerator pedal, that throttle has full throw. Because if it doesn't, you're not going to be getting, the maximum amount of power out of that controller. By the same token, you got to make sure that it goes all the way to 0. Now, the other one you noticed had the little micro switch and had the safety interlock switch, as a feature on it. This does it in another fashion. It's reading the signal, whether the signal is 0 or not. So we don't need the switch. Okay, quick little review. Make sure I didn't leave anything out. We've got types of throttles. So we discussed some common types of throttles: electronic, Hall effect, 2-wire pot, and 3-wire pot. Remember compatibility. The type of throttle that you use needs to be compatible with the controller. So your controller will basically dictate the throttle types that you can use. Placement. It should be placed on a surface that is rigid and it's not going to move when you activate the throttle. It needs to be located in such a way as that it's not going to interfere with anything and nothing's going to interfere with it. Also, it's a good idea to have it not right in close proximity to your high voltage wire. And then we talked about the connections. On your controller, it will dictate, where, based on the type of throttle, where you would make the connections. And that's going to vary based on controller selection. And then the recommendation. So this episode's recommendation is that you use a secondary spring. Like we talked about in a recent video about using the JLD 404 and the relays in the JLD 404 in a redundancy operation to protect your battery pack from overcharging, over discharging. Well, we want to run a secondary spring. It's a redundancy. It's not absolutely necessary, but I highly recommend it. If your main throttle spring were to fail, you have no way to shut off that throttle. Not that you can't stop the car, but you're in a world of hurt. It's much better and much easier if you just have that backup. It's not a big deal. We'll take a look at it real quick on our 2 examples we showed, and we'll show you the backup spring in both instances. So back at the pot box example we used, what we have here is this is the throttle side, throttle pedal side, and this side there's an auxiliary return spring right there. The main spring is down here on the shaft. So this is the secondary backup spring. Let's go take a look at it on our electronic throttle example. So on the electronic throttle, again, here's our throttle cable. Here's the stock return spring on the throttle, and here's a secondary spring right here. Basically in line with the throttle cable, so that if this main spring were to fail, we have a backup. All right, that's it for this week. As always, we ask that you address any questions or comments to info@evforyounow.com. I appreciate you watching. If you are getting something out of these weekly videos, we ask that you subscribe to the channel. And as always, I thank you for watching, and I'll see you next Wednesday.